So let's look at the third example. The owner of a grocery store thinks that he has a very good business. He looked at all the sales receipts at the end of the day, and he decided to find out whether the average of all sales received on that day was different from $150, because that was his goal, that the average of my sales, every sales received, all the things for the whole day should be about 150. So his objective is to find out whether the average sales receipt on that day is equal to or not equal to $150. Not equal to, if you read that statement, you got your alternate hypothesis right there. So your alternate hypothesis is not equal to $150. This is the population mean. So what he did, he selected a random sample of 40 sales received from that on that day. 40. That's your N. So N is there, mu is there. Then he found that the sample has a mean of $137. Now you have your M. Standard deviation is also there. So you have all the information you need to calculate your Z, and your alpha level is 0.01. Based on this information you have, it says mu not equal to $150. That's your alternate hypothesis. As soon as you see this sign not equal to, whatever the value of alpha is, that will be divided equally on both the left tail and the right tail. That means your rejection region will be on this side and also on this side. Anything in between will not be rejected. Anything you have between these two, they will not be rejected. So, based on the information, we calculated the Z-score, a test statistic, and we found it is minus 2.7. That's the Z obtained from the information we have been given. Now, alpha is 0.01 and it's a two-tail test. So 0.01 divided by 2, that's 0.005. That means on each side of the tail, we have the alpha equal 0.005. If you look at the table, then the corresponding Z value is on the right side plus 2.58, on the left side minus 2.58. So anything between plus 2.58 anything in between will be fine. But anything on this side, that means lower than this value or higher than this value, that will be rejected. So in two-tail test, this is how you find out your rejection region. And then so what do we have here? So this is 2.5, so plus 2.5 to minus 2.58, let's say 2.5. What we found, our Z-score was minus 2.7. So what do we do? Minus 2.7, or Z value here is 2.5. Anybody?
Reject null because it doesn't equal.
Yep. So we have to reject our null hypothesis That means we can conclude that the mean, meaning the average sales receipt, was significantly different from $150, or it was not equal to $150. So this is when you are dealing with hypothesis testing, we are talking about three things. Basically, you are talking about two things. One is a one-tail test, the other one is a two-tail test. When you are looking at a one-tail test, based on the information given to you, either you will have this greater than sign in your alternate hypothesis. Once you have the greater than sign in your alternate hypothesis, that means you will be looking at the right tail. If you have a less than sign in your alternate hypothesis, you will be looking at the left tail. And in two-tail test, you'll be telling you that the population mean is different from some value, or is not equal to some value. Not equal to is this sign. As soon as you have this sign in your alternate hypothesis, right away you will know that you'll be looking at both right tail and the left tail. And accordingly, you divide your alpha by 2 to get the value of alpha in each tail. And then you find out the z value, compare the z you obtained from your calculation, and see if it falls in the rejection region or not. Based on that, you make your decision.